This is the third and final video for section 9.1. It's probably the most pleasant of all three sections. This is the confidence interval method. So like in chapter 8, each hypothesis testing that we did, whether it was a mean, proportion, or standard deviation, we had three different options to do it. The first one was the p-value method, which you guys seem to like the most. Then there's a critical value method. And then this one is the confidence interval method. And I think this one's probably the most pleasant just because the formula is a little less than what the test statistic formula is for the other two equations, so or the other two methods. So what we're doing is we're trying to figure out or create our confidence interval, and it's going to involve comparing a piece on the left, a piece on the right, and then we write it as less than symbols, okay? And then we have P1 minus P2, okay, which is that piece in the middle there. Usually we just had P in the middle, but now since we have two of them, there's a P1 and a P2, okay? And then just kind of going back to when we're doing hypothesis testing, we're usually always saying for our null hypothesis that P1 is equal to P2, okay? So if I think I've showed you this 3 times already, if I subtract P2 over to be with the P1, P1 minus P2 will be equal to 0. So this number here in the middle we're comparing to 0, okay? So what we need to do is we need to figure out what P1 hat is, P2 hat, and the error, okay? And then this is the formula that we use for error, which still kind of looks disgusting, but it's a little bit easier than the other one, okay? So let's go down to the very bottom. This is going back to the example that we had for Connecticut and New York. And this is going to tell us, whether the two proportions are equal to each other. So this is going to tell us a little bit about our null hypothesis, which is that P1 is equal to P2. Okay, that's what our null hypothesis said. Okay, so I copied some information over from the front side that we knew. We know that P hat 1 is 0.117. That's the percentage of Connecticut that has rear license plates only. And then it was a little less than 2% for New York, so that's going to be our P hat 2. Okay? And then we need to figure out what Q hat 1 and Q hat 2 are, okay? Because that's what we're going to need for our formula up above. So we can figure those out pretty easy. 1 minus 0.117 is going to be that first part. And 0.883 is going to be Q hat 1. All right, I can do the same thing, but I'm going to go 0.016 for my second, for my Q hat 2, and that's 0.984. Okay, and that's what we have for that, all right? So we need to figure out what our error is, and that's the only formula that we have going on here. And the error that we have, we first need to know what our z of alpha over 2 is, okay? On the front side, they had us do a 95% confidence interval. We're still going to do the same on this side. And the z of alpha over 2, that value, is found by looking at your table at the 95%, okay? So like 1.96 is going to be our z of alpha over 2. So I'm going to put that down here for this piece of information that we need. 1.96 is going to be my z of alpha over 2. Okay? All right, so for our formula, we need, I'm just going to start slapping things in here. 1.96, and we have a big, long square root of stuff. Okay, so these numbers up here. P1 hat is 0.117. P2 hat, or no, Q1 hat, sorry, Q1 hat is 0.883. All right, over N1 is 2049. So this is the section of all the ones, the P, the Q, and the N, okay? Then we add that to all the 2's, so P hat 2 is 0.016, Q hat 2 is 0.984, and N2 is 550, okay? All right, so then we just need to figure out what our error is. All right, so let's see. I'm going to do this middle part inside of here first. Let's go down here so you can see what my calculator is doing. Right here, okay. All right, I'm going to do 0.117, 0.117 times 0.883 divided by 2049. And then I'm going to add to that. So now I'm here. Adding to that, I'll use parentheses this time, 0.016 times 0.984 divided by 550. Okay, so everything underneath of the square root right here, all of this stuff, after I've typed it all in, is this number right here. Okay, but then I need to take the square root of that. Okay, square root. So I'm going to take the square root of that answer. Okay, and that's just going to make it very easy for me to do. Enter. So this whole thing right here, after I take the square root, is that 0.00889 number. And then the last thing that I need to do is multiply it by 1.96. Okay, so I'm not really writing a whole lot down, but I'm still doing it kind of in pieces. The error is going to be 0.0174. Let's do 4 decimal places there. Okay, all right, and then I just need to write out my confidence interval. So now I have my error. Okay, confidence interval looks like this. Okay, we have P1 minus P2. Okay, so P1 hat is 0.117 minus P2 is 0.016. And then I'm going to subtract the error, which is 0.0174. We're going to say, oh, let me go back up here so you guys can see, is less than, 0 goes in the middle, okay, which is less than, and I do the same thing again, but here I'm adding the error. So 0.117 minus 0.016, and I'm going to add, let's add the error, 0.0174. Okay, so I've done what the formula set up here. I've done P1 hat minus P2 hat minus the error, P1 hat minus P2 hat plus the error over here. Okay, all right, so if I type this all in at one shot in my calculator, if I do this left side, okay, parentheses, 0.117 minus 0.016, close parentheses, minus 0.0174. All right, and this guy's going to be 0.0836. Okay, is less than 0, which is less than. All right, and then since I've typed it all in at one shot, I'm going to go back up into my calculator. Instead of it being minus 0.71 or 0.0174, I'm going to do plus, and that's going to give me 0.1184. Okay, all right, now, okay, we're done with all of our calculations and everything. Now we just need to come up with a conclusion. Okay. And this confidence interval will tell me what to do with this guy. Okay, am I going to accept or reject him? If P1 equals P2, then that means that P1 minus P2 equals 0, basically, is what we're saying here. Okay, and so we will say that this is good, or we will fail to reject this if 0 lives in between our two numbers that we got. Okay, so we ask ourselves, does 0 live in between 0.08 and 0.11. This would be like 8% and 11%, right? Does 0 live between 8% and 11%? No, this is false. So that means that we are going to reject the null hypothesis, okay? Which we already kind of knew from the front side, but this is just another way of finding it. And really, I think this is maybe a little bit less work than the other one. I kind of like this one a little bit better, just because it's less numbers to have to deal with. But you know, whichever method you think works the best, you know, I'll again give you kind of the option at the end when we get done with the chapter. But I want to present all the options to you so that you know any of these methods will work. What I'm going to have you do for the homework assignment is you guys did or should have done number 1 and number 3 part A. Okay, I'm going to have you do number 3 part B, which is the confidence interval for this guy. So if you have everything all written out, you should be able to do the confidence interval using those numbers. And these numbers are fairly small, so 377 and 2082 and 241 and 51. Those aren't terrible large numbers, so you won't get the superly ugly decimals like what we got up here. So you should get some decent decimals to deal with when you're writing your equations out. So do number 3 part B, add that to your homework. We won't do number 5. We won't do number 5, but go ahead and do number 4, parts A and B. Okay, and C, I guess. C is going to have a question for you at the very end. So that's just kind of like a, based on this, is it equal? Does that mean it's equal? So go ahead and do those. I know that this is kind of cumbersome and really awful formulas, but the more you do them, the easier they will become, and the more familiar you'll get with your calculator. Okay.